Hello, so the problem says a block of mass M1 equals 5 kg is on a rough horizontal surface with coefficients of kinetic friction of 0.7 and is connected to a hanging block of mass M2. The block M1 is pulled to the left by a force F1 parallel to the surface, which causes it to speed up to the left. Provide reasonable values for F1 and M2 and find the acceleration of each block. Include a free body diagram for each mass. Okay, so for M1, the free body diagram, you first want to start with, first of all, the masses of each. For M1, this is 5K, and I just made this up, and this is going to be 4 kg. So first, for your free body diagram for M1, you're going to draw your center, and since, you know, the normal force is going up, the weight is going down, so it'll be M1G. And since it's being pulled to the left, the applied force is going to the left, so that'll be FA. And since the friction is opposing it, this will be FK. And for your second free body diagram, since M1 is being pulled to the left, is going to accelerate upward, like the force is being pulled upward. So you're going to draw your center, and your applied force is going up, and the weight is going down. And so you want to separate your x's and your y's, so the sum of fx equals m1ax, and the sum of y is fy equals m1ay. So looking on the x side, the sum of x, since fk is going to the right and your applied force is going to the left, your fk will be positive, your applied force will be negative, and that equals to m1a. And so the definition for kinetic friction is mkn minus fa equals m1a. So now looking on the y side, the sum of fy equals may, so that will be n, the sum of fy is n minus m1g equals 0. So ultimately, n just equals m1g. So you can plug this value of n into right here, and so that will be mk m1g, since n equals m1g, minus fa equals m1a. And so now we can look at our second free body diagram. And so that will be f, the sum of f equals the sum of f equals m2a. So the sum of that would be, since fa is going up and m2g is going down, fa will be positive, so fa minus m2g, since it's going downward, equals m2a. So we can combine what we found here for our second free body diagram from our equation that we got from our first free body diagram. So it'll be negative fa. I just arranged it so they would cancel out. Negative fa plus mk m1g equals m1a. So if you put that all together, these two cancel out, and so that will be MK M1G minus 2G equals M1 plus M2A. We're trying to find the acceleration, so you put A on the outside. So now, having these equations, we can find the acceleration, which would be, well, I ain't got no room. So A equals MK M1G minus M2G over M1 plus M2. And so for that equation, I'm gonna put it over here, it would be A equals 0.7 times 5. This was the value of our kinetic friction. This is our M1, 9.8, that's G, minus 4, that's our M2, times 9.8, which is a G, over 5 plus 4, which is our M1, our M2. And then you add those up, and I got negative 0.5 meters, 5.4, I'm sorry, meters per second squared. Thank you.